There's one last very important topic relating to correlation, something that you probably heard in a science class that we need to discuss as well, which is that there's a difference between correlation and causation. Now, causation means that one variable causes another. For example, if there's a dog walking down the street, my dog is going to bark at it. So if you hear a dog in the background, that's my dog. So the action A, which would be the, dog walking down the street, leads to action B, or outcome B, which is Alana's dog barks. Dog in the house barks. This is the second time I've had to make this video due to my dog barking. All right, so that's a causation, right? The one action is going to cause the other. Correlation measures the relationship between two variables. So for example, action A relates to outcome B, but A doesn't necessarily cause B. All right, so that's key, that you can have causation and you can have correlation. Now, if the variables have a cause-effect relationship, then they're definitely going to have a correlation. So, for example, this dog walking down the street and this dog barking will have both a correlation and a causation. Since one thing is causing the other, they will definitely have a correlation as well. Right? But variables that have a correlation don't have to have a cause-effect relationship. Right? It's possible that two variables are related to each other, but it's not that one is causing the other. For our purposes, it's not possible to prove correlation from observational studies, right? So we can get a little more fine-tuned into that in an upper level class, but for our purposes in this class, we'll just say that we cannot prove causation from an observational study. Only experiments, and at that they have to be very well designed experiments at that, can show cause effect. A lot of experiments, if they're poorly designed, will not show cause effect either. All right, so let's consider the following diagram. We have three variables A, B, and C. All right, now A is snowy weather, B is hot chocolate sales, and C is the time spent sledding or skiing or snowboarding. Pick your winter sport. All right, so put the tips on the arrows to show the directionality of the relationships and label them as causation or correlation. Okay, so snowy weather causes hot chocolate sales, right? That's a causation. It's also a correlation as well, but it's a causation, right? So over here we have causation and correlation. Wherever causation goes, correlation will follow, right? If snowy weather causes hot chocolate sales, then they're also correlated to each other, right? But that's less of a big deal than the causation. Right, over here, similarly, we have another big arrow. Snowy weather causes us to be able to go out and spend time sledding. Although I haven't been sledding in years. I enjoy it, but I never think to do it. Correlation as well, right? Because if there's a causation, then there will be a correlation. But again, I'm really looking for the causation here. I just want you to realize that that's also a correlation. All right, now what about these two, right? Hot chocolate sales and time spent sledding. Well, there's definitely a relationship, right, between the two, but it's not that buying more hot chocolate or selling more hot chocolate makes you go spend time sledding, right? So this is just correlation. There's no causation down here. These two variables are correlated but not causated, right? If that's a word, right? They have a correlation between them, but there's no causation. I'm just going to put the correlation there and just put just in the background, just so you realize it's just correlation, no causation. Okay, so let's look at our true and false here. True or false? A, which is snowy weather, causes B. Well, that's definitely true, right? This is a causation angle here. Now what about B causes C? No, no, no. This is just correlation. There's no causation here. So that's a false. True or false? There is a strong relationship, strong correlation between A and B. Oh, totally true. right? If they're causated, then they're going to have a relationship between them, a correlation between them. And then true or false, there's a strong correlation between B and C. Well, yes, absolutely true, right? These two things go together very strongly, right? I live in Michigan, so we have this all the time, right? Hot chocolate sales and time spent sledding, right? They're correlated, right? But they're not causation. See the difference? All right, so variable A, which is the snowy weather one, has a special name in statistics, which we learned in section 1.2. It's called a lurking or confounding variable. I'll just put that, aka confounding variable. There is a slight difference between the two, but we won't get into the difference in this class. We'll just treat them as if they're the same. Right? So lurking variable, also known as a confounding variable. Either one works, but I use the word lurking variable most of the time. Okay, so let's see how that relates to the next page. So while correlation and causation can exist simultaneously, right? For example, the snowy weather and the hot chocolate sales, right? That was both correlation and causation, right? So it is possible that they exist simultaneously, but correlation alone does not imply causation. That's the key, right? Just having a correlation down here between these two doesn't mean that this one causes this one or vice versa, right? B doesn't cause C, C doesn't cause B. They're correlated, but they're not causation, right? There's no causation between the two. And that's what it means when people tell you correlation is not causation, right? Correlation is not causation means that just because two things are correlated, it doesn't mean that one thing causes the other, right? Often that's because there's a lurking variable. There's a third hidden variable that's in the background that's not accounted for in the study. So if you think of the diagram you looked at, so up here you have your lurking variable. It's not accounted for usually in this study. Right? It's something else that's lurking in the background. That lurking variable affects variable 1, or we'll call it variable x, and this variable y, right? So we see variable x and variable y, which will lead into those letters more in the next section, right? But x and y have a correlation. So this is correlation here. This is causation. Here and here. So this arrow is a causation arrow, this arrow is a causation arrow. These two variables are correlated. And what's happening is when you look at a study, people are saying, you know, hey, I see a relationship between two variables, right? Therefore, one causes the other. No, 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 right? Seeing a correlation doesn't mean that these two are causing each other. It usually means there's something else lurking in the background that's causing them. And that's our script right here, right? Our kind of generic language that we use, right? Correlation is not causation because there are lurking variables such as blank that are affecting the study. And then what would the blank be? So you fill in the blank with specific example, usually just a specific example, but specific examples from the context. Of the situation. All right, so let's see an example of this in practice. So in May 2023, a study was released in the United Kingdom. This was a real study about claiming that kids that were breastfed for at least a year were 39% more likely to do better on math and English exams at age 16 than those who had not been breastfed. Well, that's actually true, right? For one thing, this is a real study. You can, if you go to the electronic file, you can click on these links and see the sources. This is a real study and it really does show this. Okay, so what's happening? We have kids that are breastfed for at least a year, right? So that's variable over here. That's variable x, right? So x would be breastfed for at least a year. That's variable x. And variable y is the scores on these math and English exams, right? Scores on math and English exams. And what's happening is there's a strong correlation between the two. This is a correlation. Right? Kids that were breastfed for at least a year do in fact do better on their math and English exams. But is it the breastfeeding that's causing that? And the answer is no, it's not. Right? There's something else. There's another causation factor, a lurking variable. And if you think about it for a minute, and actually one of these sources I think leads to the podcast that I listened to this about, it's mother's wealth. So the wealth and education level of the mother. If a mother has more degrees, she's more likely to have a good job, which will let her stay home and breastfeed her baby for a while, right? So having a mother that has a high wealth level, right, means that she can afford to not work for a year so that she can be breastfeeding her child, or she can afford equipment so that she could bank milk and breastfeed her child, right? You see what's happening? So this is what's happening, right? This is affecting, this is a lurking variable. Oh, I should have put that up at the top. I always want to label these. So that was variable X, that's variable Y. This is the lurking variable up here. You can probably squeeze that in, and then I'll just say wealth and education of the mother. All right, so does this study show that breastfeeding for at least a year causes high exam scores? No, right? Correlation is not causation. Because there are lurking variables such as maternal wealth and education. See, fill that in with a suitable lurking variable for the situation. In this case, I've got two of them, right? Maternal wealth and education. Oop, there's my dog again, sorry. That are affecting, you could say is if it's just one lurking variable, that are affecting the variables of the study. And we will use both diagrams like this and this script many times to explain why correlation is not causation for different studies in our notes and worksheets. So you will see this again.